All right, Mr. Emmett here for 9.1 part 2. Goal for today is to work with the converse of the Pythagorean theorem. So we practiced working with the Pythagorean theorem in our previous lesson, and in that we determined that for any right triangle, the hypotenuse squared was equal to the sum of the lengths of the legs squared. So if we are to check this out without knowing that it's a right triangle, if c squared, the hypotenuse squared, is equal to the leg squared plus the leg squared, then I would know that it is a right triangle. So we're going to take these values to check to see if it's a right triangle by plugging it into the Pythagorean theorem. So our first one says, I have 8, 7, and the square root of 113. I need to determine if that's a right triangle. So the first thing I want to do is see what about the square root of 113 is. And that is approximately 10. So I know that that's the longest side, so this has to be C. I do want to check to make sure it's the longest side. So there's my C, and I can let this be A and B. I have to check and see if it's equal or not. So is 8 squared, or the square root of 113, we'll start with that. Square root of 113 squared, is it equal to? We aren't sure. 8 squared plus 7 squared. We are going to check. So squared and square roots cancel each other, so this is 113. And then we have to take 8 squared plus 7 squared, and I'm doing that with a calculator. 8 squared plus 7 squared is 113. They are indeed equal. So since these are equal, I can state that it is a right triangle. So, and it is a right triangle. I can't name it. Doesn't have any points. And I'm just going to write, yes, a right triangle. Now we'll check the next one. 4 times the square root of 95. I need to see what that is about just to make sure that's the longest side. And that is approximately 38, so it is indeed the longest side. So, is 4 times the square root of 95, whole thing in parentheses, squared. Is that equal to 36 squared plus 15 squared? Now, that's calculator work for me for the most part. However, if you do this without a calculator, don't forget to square the 4. These cancel, but we still have to do 4 squared. 4 squared is 16 times 95. That's what we're getting over here. 16 times 95. 16 times 95 is, using a calculator for that, 1520. See if that's equal to 36 squared plus 15 squared. Using a calculator for that, I get 1521. So those are not equal. So it is not a right triangle. Okay? C squared is not equal to A squared plus B squared. Go ahead and hit pause and give the next two a try on your own. All right, hopefully you had some success. 3 times the square root of 34. Again, you got to see what that is. And that is approximately 17.49. I just typed it into my calculator to see. So that's the longest side. So 3 square root 34 in parentheses squared. Is it equal to 9 squared plus 15 squared? We got to check. So 3 times the square root of 34. Don't forget to square the 3. This is 9 times 34. 81 plus 225. 9 times 34 is 306. 81 plus 225 is 306. They are indeed equal. So since they're equal, it is a right triangle. And checking the last one, didn't have to do any extra work. I know this has to be C, A, and B. Again, I should have put C, A, and B over here. I didn't do that right away. So C across, it's the longest side, 26 squared. Is that equal to 22 squared plus 14 squared? And 26 squared is 676. 22 squared plus 14 squared, 680. Those are not equal, so not a right triangle. Does not satisfy Pythagorean's theorem. So when it doesn't satisfy the Pythagorean theorem, if c squared is less than a squared plus b squared, then the triangle is acute. If c squared is greater than a squared plus b squared, then the triangle is obtuse. So we're going to follow the same procedure, and we're going to check to see if it's an acute right or an obtuse triangle. Before we can do that, though, we have to verify that it can be a triangle. And for it to be a triangle, the two shortest sides have to add up to more than the longest side. So in this case, when I check, 4.3 plus 5.2 is 9.5. All right, this cannot form a triangle because if I have this 16.1 foot piece down here, and I got a 4.3 foot piece here, and a 5.2 foot piece over here, those two pieces are never going to touch. So it can't be a triangle. So can't be a triangle. Those do not work out, all right? For this to be a triangle, one of these needs to be bigger. These two smallest sides have to add up to more than the largest side. So again, when I check here, 3 plus 4, those are the two smaller ones. That's bigger than 6. So yes, it can be a triangle. So now from here, we would set 6 to be the c, so 6 squared. Is that greater to, less than, or equal to 3 squared plus 4 squared? 36. 3 squared is 9 plus 16 is 25. So in this case, c squared is greater. This was my c, this was my a, and my b. So since c squared is greater, I would state that it is obtuse. And my last one, check to make sure, 2.8, 2.1, that's more than 3.5, we're good. It can be a triangle. So this has to be C, A, and B. So 3.5 squared. 2.1 squared plus 2.8 squared. Let's see what we got here. 3.5 squared is 12.25. And 2.1 squared plus 2.8 squared, 12.25. So since those are equal, it is a right triangle. All right, that's all she wrote. Have a good rest of the day.